Good morning. Today we are moving on beyond Unit 5, which many of you will be relieved. We don't have all of those identities. I would say this is a little bit more concrete, and you did have some exposure to vectors back in geometry. And I think you'll find it's a little bit more black and white than in that gray area, and where do I start? So today Unit 6 is on vectors. So first of all, let's go back and recall what is a vector. A vector is a quantity that has direction, and it has distance, and we have a technical name for that, and that is called magnitude. And you can see down here, here's an example of a vector. It just looks something like the following. Notice you do have to have an arrow at the end of it. That lets us know which direction that we're heading as well. It has an initial point, which is its starting point, and it has what it's called a terminal point, which is where it ends. So in this particular case, here's my initial point, here's the terminal point. The distance from that starting point to the ending point is called the magnitude. And if you think about back to geometry, we've got two different ways to find distance between 2 points. We've got the distance formula, and if you recall that, that is where you subtract your x coordinates, square that, you subtract your y coordinates, and you square that. And certainly that's one option that you can use to find the distance between those 2 points. The more common way that we tend to use is Pythagorean's theorem. And that's really what we'll focus on. The direction corresponds to the direction the arrow is pointing, and we're going to talk about a couple different ways that we can denote that direction, and we've mentioned these before. One is the compass direction. One is polar, and the final one is bearing. And again, really, we've dealt with all of these somewhere along throughout the semester as well. It can also be represented by coordinate pair in the coordinate plane. This is called the component form. And it looks like the following. We put x comma y. Notice we're not using parentheses, but we're using the brackets. That denotes that it's a vector and not just an ordered pair. So let's take a look at this specific vector right here. Its magnitude is this length right here, which is the 65 units. The 50 degrees, again, there's a couple different ways we can talk about it. If we were going to do it in compass form, we would have 50 degrees south of east. If we were doing in polar form, remember that's with respect to the unit circle. So remember the unit circle, I'm always starting here. If I'm going this direction, that would be negative 50 degrees. Or if I was going all the way around the unit circle, well, all the way around the unit circle is 360, but I'm subtracting that 50. So that could also be 310 degrees. And again, that is in polar form. And finally, the last way that we talked about, again, is that bearing. Remember, bearing, you start from north, and you are going clockwise. So that would be 90 plus the 40. So another way I could denote that would be 140 degrees, and again, that would be bearing. So really today we're just going to be focusing on looking at the information that's been given and then rewriting it in whatever form they've asked us to do. In this particular case, our initial point is point O, which obviously our coordinates are 0, 0. Our terminal point is down here, which is point L. We don't know these exact coordinates, but we can see it would be whatever the x is, whatever the y is. And then finally, you've got your component form, which would be that x comma y. Now, the only time these are going to be exactly the same, if you can imagine, is if my initial point was at the origin, but we'll certainly be looking at vectors that don't necessarily start from the origin. Okay, there are two formulas that I just cut and pasted from your textbook. The first one is the magnitude, and really we talk through this one up above. If you take a look here, this is that distance formula that I alluded to at the top. And that is going from this initial point to this point right here. If you had it directly in component form, which is what we have here, the other way we could do is just go and use that Pythagorean's theorem. And again, we'll look at a couple of these, just denoting again some symbolism here. Take a look. So when it says find that, that means they're looking for the magnitude. They're looking for the distance or the length from that initial point to that ending point. And if you also go on to the IXL links that I gave you at the bottom, it goes through some quick examples of just confirming that you know how to find the magnitude as well. Then let's take a look at the second formula they gave you. And again, I wouldn't necessarily feel like you have to memorize these. Some of these actually might be on your formula sheet as well. But I'm going to kind of walk you through how do we get to these values without memorizing. So in this particular case, if we're looking for, it says the direction, and we're looking for the components. For example, let's suppose we had this angle here was 40 degrees and we had this was 50. We can quickly convert this right now. This would be polar form. It's 50 units with a 40-degree direction. To quickly convert it to component form, they're taking the magnitude times the cosine of that angle and the magnitude times the sine of that angle. And actually, let's take it one step further. This is one of those we probably could quickly derive for you. So let's go ahead and do that down here. So in other words, if this was theta and this was our magnitude, let's say, I'm just double checking here. V, if I'm looking for x and I'm looking for y, which would be the components. Well, think about this is adjacent over hypotenuse, so that would be cosine. So cosine of theta equals x over v. So when I go and solve this, my x component is v, which is that magnitude, times the cosine of theta, which is what they have in here. And I think this is a v, not a y like it looks. If I wanted to go and find the y component, again, opposite over adjacent, we would have sine of theta equals y over v. So when I solve this, I get y equals, again, v times the sine of theta. So just trying to show you how they came up with that formula. Again, if you don't remember it, though, we can go ahead and drop that in and go and find those coordinates by doing SOHCAHTOA like we just did. Okay, so we're going to go and look at two examples and just kind of go through each of those forms that we talked about today. So the first one, we've been given this vector right here from O to L. And we're going to go through and write it in each one of the different forms. So remember, compass form is a degree. Might be nice if I can spell. With respect to north, south, east, and west. So in the first example then, again, we're going to look at this one right here. We've got 65 units, and this one is 50 degrees south of east. And while we're here, let's just go ahead and jump because we kind of did this on the front already. If we want to go do it in polar form, the way we write that is we write the magnitude, comma, theta. The only thing you have to remember is that theta is on the unit circle. So in this particular case, our magnitude is 65. We would either do negative 50 degrees Or we could go and do, as we said, if we go all the way around the unit circle, that would be 310 degrees. Okay, if we were writing this in bearing form, then again, we've got magnitude, comma, theta. The only difference on this one is, remember that theta starts from north, and it has to go clockwise. Okay, so I went and filled in that last one just to save us a little bit of time. Now we're going back up to component form, and we talked about that. That is x comma y. So in this particular case, I can go, if I'm solving for x, I have adjacent over hypotenuse. So that would be cosine of 50 degrees equals x over 65. I would do the same thing when I'm looking for y. That would be sine of 50 degrees equals y over 65. Now you can set it up that way, or if you look at the formula on the front, it said to do that we do magnitude cosine of theta, magnitude sine of theta. So you can use that formula, or you can set it up like the following. When I plug that in, I'm coming up with 41.8 comma negative 49.8. Okay, now we're going to go and do the same thing for the second example, but in this particular case, I've not been given a picture. This is the information I've been given. I'm going to go ahead and pause and draw that out for us. Okay, so I went ahead and drew out what I was given. Here's my initial point, here's my terminal point. What I'm going to try and do is just rewrite it in standard form, so it's originating at the origin. So if you think about, if I'm starting at 1 and I'm ending up at 5, that means my x component would be 4, because I'm going 4 units to the right. For my y, if I'm starting at 2 and I'm ending up with negative 6, that means I'm going down 8 units, so my y coordinate would be negative 8. So that means I can rewrite it in standard form, starting at the origin and ending up at that point for negative 8. So that means in this particular case, we actually have the component form. We've got 4, negative 8. So when we write it in that compass form, or any, the polar, the bearing, the first thing we need to do is go and find the length of that vector. I've got 4 here and 8 here. We can either use the distance formula or we can use Pythagorean's theorem. I'm going to suggest let's use Pythagorean's theorem. I'm going to pause, give you guys a minute to go ahead and do that. Okay, using Pythagorean's theorem, I ended up with a radical 80, or 8.9 units. Now the second thing I need to do is go and find this angle in here. So again, notice you have opposite over adjacent. So that means I've got tangent of theta equals 8 over 4. That means theta is equal to inverse tan of 8 divided by 4. And when I do that, I ended up with an angle of 63.4. So that angle is 63.4. Okay, so with regards to the compass form, we ended up with 63.4. If we're writing it in compass, that means we are south of east. We figured out on our own we had component form. Let's go down to polar form. Remember, polar form is the magnitude comma the angle on that unit circle. So again, we've got two ways. We could write it as negative 63.4. Or if I went all the way around that unit circle, we've got 360 minus 63.4, and we've got 296.6. Then finally, if I wrote it in bearing form, again, I want the magnitude and I want comma the angle, but remember, bearing again starts from north. So again, I'm starting here, I'm adding that on. When I add the 90, plus that 63.4, I ended up with 153.4 degrees. Okay, that's it for today. As I said, most of this you've seen as review. We didn't do bearing form back in geometry, but at least you had some exposure. As always, send me an email or post on the discussion board if you have any questions.